Good afternoon, this is Schweitzer, and we are going to walk through a couple different types of calculations for bond energy. Now, bond energy is another way to calculate what we call delta H. Now, delta H is the amount of energy you get when you cycle through a reaction, enthalpy. So if I have X going to 2Y, in this situation, if it's exothermic, you could, well, it doesn't matter, I put my delta H right here, and I get a certain amount of energy. A couple things you'd want to understand is that this is, if it's 1 mole of this and 2 moles of this, okay, there's a mathematical relationship for this. After 1x goes through, I get this amount of energy, question mark energy. If I had 2 moles going to x going through, I get 2x, 2 question mark. A couple things we might want to point out about this is that how is energy related to bonds, breaking bonds forming? This is probably one of the biggest misconceptions that we have in chemistry, and I don't know where it comes from, but when you break bonds, okay, if you need to break 2 x's apart, you're actually taking energy, and you need to physically rip this thing here and rip this thing here, okay? With that being said, energy needs the input. So anytime you break bonds, you need to add energy. That's going to be right here. Okay, you're going to add this energy that's needed to break these bonds. Then, when you form bonds, if 2 x's come together, then to form a new substance, let's say Y or whatever, then these are two things that are going to come to them. They're attract automatically. You don't have to do anything. Okay. And therefore, energy is just released like a ball rolling down a hill. So energy in, energy out. So whenever we do this, we could say we have, let's say, x goes to 2y. You could always have energy on both sides. This is the energy needed to break, energy input. This is for breaking. And then you get energy out as well if you're forming any bonds. Out when you're forming bonds. This is an endothermic end, and this is the exothermic end. And what are you? Are you exothermic or are you endothermic? Well, it really depends who's bigger. You know, I mean, if the bonds broken is bigger than the bonds formed, well, then you'll be endothermic because this is bigger. If the bonds formed is bigger than the bonds broken, then they'll be exothermic. So that ends up just tipping the scales one way or the other. Here is an example, okay, how this works. So let's just try and walk through our first example of this. And the first example, I'll just give the formula for it. It's a little bit different than it's backwards from some of the stuff we normally work with in this chapter. It's bonds broken minus bonds formed. This next thing you do is you write all those structures to see what's actually broken. This guy here is this, and there's 2 of them. I got O2, looks like this. I got water. Two of these guys. And those guys are worth 104. One of these guys, which is 119. 4 of these guys, which is 111. Alright, so now we're going to take bonds broken minus bonds formed, and there's a picture of all the stuff we got. Okay, so let's add all these up, and it's going to be, this would be 208 plus 119. Alright, and we'll get 208 plus 119 is 327. So I'm adding in 327 kilojoules of energy to break all the bonds. And then I have to get back negative, which means energy is being released, 411. That's this guy. So I have more energy being released when I form these bonds than when I break these bonds. So this is going to be exothermic. And therefore, do subtraction, and you get your answer. I'm assuming you can do that to subtraction. And the answer is right here. Okay, there's all the work we did. If you want to pause the video and try it on your own. Here is another version. I'm going to pause this version. We only have one or two different versions here we're going to do, and this one is for you to try. All right. Pause the video, try it out. All right, pretty standard question here. We got CH4. We're going to burn it. Anytime you feel like you can complete the problem, if you haven't yet, just pause the video and complete it on your own. CH4 plus O2 yields CO2 plus H2O. You balance it. One carbon, 4 hydrogens. Put a 2 here. 2 and 2 is 4. You put a 2 here. Sketch out some Lewis structures. Okay. And at this point, going to, and then we got waters, we got 2 waters. Okay, so this will be worth some decent points. They like this because it's got a lot of little things you can do with it. Alright, so now I got, they'll literally have a point just for getting and adding up all these pieces. So we got 4 CH bonds. We got 2 O2 bonds. 2 carbon O bonds. Here's one, here's the other one. And I got 1, 2, 3, 4 OH bonds. Alright, so now I'm not going to go through the whole work on this thing because you can do it on your own. The rest of it is just a coasting out. Assign a value for each one of these. You'll need a table for that where that information is provided. And then you add them all up. And you do the broken minus form. A couple of things again, remind this is not the most accurate way to do it because it doesn't take into account whether it's a gas, a liquid, or any intermolecular forces that are involved. So it's just on the covalent side, that's it. Here's an alternate version of what you might see here. Okay, it's really, this is the last little version. Only other way they might twist it around. In this case, they give you the entire thing. They give you delta H, and they want you to backtrack for one of the individuals. And again, I'm just going to show you kind of generally how this works. So here's methanol, and I want this bond right here. So bond, it's already set for. You just got to go ahead and just kind of walk through how this works. We got methanol, which is going to be, so what I got broken here, I got this guy, all of these guys. And I actually got 2 of these guys, just keep in mind. Okay, and then I got 3 O2s. 3 O2s. I got 2 of the CO2s. So that's going to be 4 of the COO bond. One too many of those lines there. And then I got 4 waters. Now water, of course, looks like this. And I got 4 of those with 8 OH bonds. All right, hopefully you got that. Now you'll assign a value to this thing. It's going to be on this thing here. I got 1, 2, 3 of the CH bond. I don't know what that's worth. All right, so that's my unknown value. And then I got 1 CO bond, 1 CO bond, and then 1 OH bond. Okay. And we're going to make just a math problem out of this. Okay, and it's going to be 3, which is this guy, x is the unknown value. plus, we got CO, which is 336, plus this guy right here, 446, plus 3 times the O2 bonds, 498. All right, this whole thing gets put together. Well, we're missing the piece there. We're going to use algebra and correct math routines minus all the sum of everything else. So it's going to be, all right, we got product-wise here, we got 4 CO bonds, C double O here, 805, plus 8 of the OH bonds, 464. Now you notice you do have one on both sides, and you could obviously cancel that. Only thing that really would be included are the things that are actually broken. So they may not give you a piece. If they don't give you a piece, it's because it's not broken or it's not formed, or they want you to find it. So at this point, we're going to stop the video here, and this equals the delta H, which is going to be 1360, negative 1360. And I'm assuming you can put all this together, knock it over here, put all this together, okay, knock it over, and keep in mind this whole thing, then negative gets distributed in here, okay? So just either way, I'll let you figure that out. A little bit of math. Any questions on the math, please see me or let me know.